Hello, my name is Ryan Miller and I'm an undergraduate researcher at Texas A&M University. My research covers the characterization of deep water currents located between the Mid-Atlantic Ridge and the Rio Grande Rise. In the winter of 2016, the CREST, which stands for Crustal Reflectivity Experiment Southern Transect, expedition acquired multi-channel seismic and ocean bottom seismometer datasets along a crustal segment stretching from the Mid-Atlantic Ridge to the Rio Grande Rise, which is seen here. During OBS recovery, a communications problem occurred in which the OBS received the transducer pulse from the ship, but the ship did not receive the OBS return pulse. We hypothesized that a deep water layer of differing physical properties, potentially Antarctic bottom water, which is a dense water layer that enters this area through the Vema channel, was present in the water column and dispersed the return pulse. We are processing seismic reflection data to image reflectors that represent changes in salinity and temperature related to currents in the deep water. These reflectors will be used to better characterize the deep water currents in order to gain a better understanding of their nature. Here you can see the processing flow used for this data. Specifically, I'm going to highlight that in my results you can see that the deep water column and the shallow water column are separated. This is because we use a low pass filter for the deep water column, while we use a band pass filter for the shallow water column. This was an attempt to better image long wavelengths. I've highlighted areas that I think potentially could be high amplitude, laterally continuous reflectors in the deep water column, but are masked by noise. Conversely, in the shallow water column, you can actually see high amplitude, laterally continuous reflectors. Here I show data from Quisto, which was acquired closer to the Mid-Atlantic Ridge. And you can see directly the impact the Mid-Atlantic Ridge has on the data. Specifically, above the Mid-Atlantic Ridge, the data is lower amplitude and less continuous. The eastern and western portions of this data set both image the upper water column well. These reflectors are likely associated with currents related to the South Atlantic Gyre. Variation in reflected geometry with depth of location could be due to differences in temperature and salinity associated with current layers. In Figure 5 here, I show satellite data acquired during the acquisition of Line 1B. Satellite data may be used in conjunction with seismic data of the water column in order to determine the effects of the South Atlantic Gyre currents on the water column. Lower frequency sound waves used in seismic oceanography are coherently reflected directly by the thermohaline boundaries between water masses, according to Wood et al. 2010. As such, they give direct insight into the temperature and salinity profile of the region. The circle trends in the deep water column data of the results section could potentially be associated with a density-driven bottom current. Here I give my conclusion and future work that I will be doing. Further investigation of the data derived from the study area is warranted to better characterize the circulation of ocean currents. While the data does not conclusively show that Antarctic bottom water, or a comparable body, is present in the deep water column of our study area, future work may help us to better resolve these portions of our data set. Although Antarctic bottom water was not proven to be present, its existence was not excluded. Further processing refinements, such as the implementation of seismic unit code for direct wave removal, will also be researched and implemented in an attempt to obtain better imaging of the deep water column. Additionally, investigation into the effect that South Atlantic gyre currents have on seismic imaging of the water column will be undertaken. Ocean temperature and salinity parameters will be inverted from combined hydrographic and seismic data to aid in this investigation. Additionally, here in Figure 6, I show an anomaly of fanning divergent reflectors. This is seen best in line 4, but is also present in other lines, such as here in line 1B. The hypothesis that I have is this is due to a hyperbolic zone of mixing caused by the mixing of two different water masses of different temperatures but the same density profile. I believe this shows up best in line 4 because this is a north-south line, while the other lines are east-west. If you look at the satellite data here, you can see that the currents flow this way, so that the mixing would be best characterized in a north-south line as they would mix more directly, while an east-west line would be more indirect. In the future, I will try to better characterize this area by examining what water layers are at differing depths, as well as what their temperature profile is, and better characterize every parameter associated with their physical properties. Thank you.